Welcome, everybody. And what we're going to talk about today is leveling up. So how can you empower security operations with artificial intelligence? And specifically, a couple of the key areas that we'll look at. We'll do a quick introduction, fast overview. We're going to look at how we can leverage AI in kind of three key areas to really drive some efficiencies in your security operations. And those areas are investigation, so really kind of thinking about that as analysis and triage. Your analyst team, detections, your detection engineering team. What can they do to speed that process up? And look at threat hunting a little bit too, kind of three key functional areas in the SOC. Now obviously we know there's hundreds of areas, hundreds of things that you can do and everything. But we'll introduce just a couple of different strategies along the way and some tips, some techniques that might actually help you. So who am I? So my name is Mike Eplin. I live in Tampa, Florida. I was actually born in that picture in the upper right-hand corner, grew up at least in a little small town, middle of nowhere, Illinois, of about 1,000 people, so very small kind of rural area. And I grew up out in the country and raised horses, and both my grandfathers were farmers, all that good stuff. I'm a security advisor at Google Cloud. So that role, I work with our larger customers on their implementations of Google SecOps, security operations, so SIEM, SOAR, how it integrates with other products, integrated into their workflow and into different solutions. There's kind of my work history, kind of long and varied, U.S. Air Force veteran. There and ended up at Google. A lot of this has been a series of acquisitions kind of throughout my career here. Early on in my career, at a company called Open Service, it was one of the early vendors, morphed into a company called LogMatrix a few years later, just really a rebranding. I worked with a couple other people and we developed a risk correlation, it says double risk, but shouldn't be, but a risk correlation engine prototype that we actually put out. We tried to sell. We got a few customers, but not enough funding to continue. Eventually sold that off to Nitro Security, where I ended up, and then McAfee and so on, all the way over here to Google right there. You see pictures there, my grandson, 4 kids, dogs. Some of my hobbies, diehard St. Louis Cardinals fan and a Tampa Bucks fan, which has actually made it easy to be so far this year, at least 2 games in, and grew up playing soccer. My mother was born in Germany, so therefore that's the Bayern Munich connection right there. With that, so I'll talk about some challenges in security operations in some of these key areas just to kind of. So look at analysis and triage. Think about your SOC analysts. What do we hear all the time? Alert fatigue, alert fatigue. Just too many false positives, too much time trying to separate, what is what, what's a real threat, what's a positive, how many false positives they have to go through. And we see a lot of organization there. A lot of times we simply, on the detection engineering side, getting better, but used to just assign random priorities or say, all right, well, the analysts, they'll actually figure that out. But that takes a lot of drives and takes a lot of time to actually do those kind of things. Minimal context inside of those alerts. We've seen analysts do this way back years ago. We used to call it prairie dog correlations. If you've ever been out in the American West, Dakotas especially, see the prairie dogs, it's like a whack-a-mole game. They pop their head up out of the ground and go back down if they see anything. You'd almost see the same type of thing in some network operation centers or security operation centers back in the early days. Somebody would see an alert and they'd pop their head up and yell down to somebody that had access to all the firewall logs possibly, and hey, did you see anything that looked like this last night? Can you tell me what happened? Send that data over to me. I'd be back and forth trying to figure out what actually went on, trying to gather that context. And then when you're lacking that context and you're lacking that prioritization, it really hampers the ability for your analyst to get the bigger picture. So you've got an alert coming in and it looks like it might be critical, something that you need to respond to. But is it isolated to just those systems in that alert? Is it something that's spreading? How does it actually affect your environment, your critical hosts, and so on? So we'll talk a little bit about that. We'll talk about detection engineering, that detection piece of it. Some of the challenges you've got there. These complex, these very dynamic data sets. The more and more we expand our enterprise, the more applications, the more platforms, the more cloud usage, and so on, the more and more logs that we create, And the bigger volume that we have, so we've got these very complex sets. As we get into back years ago, it's kind of simple. See a firewall log, it was basically an IP and a port, and just a little bit of information. Okay, it tried to connect, it was allowed, it was denied, it was blocked, whatever it was. Now you look at some of these, logs that are especially out of like EDR and cloud applications. Huge volumes of information in there. Sometimes they don't even fit into parsing models. You have to extend models and so on to get all of that data out of there, and probably still missing some along the way there. And talk about threat evolution, threat actors. I mean, constantly evolving their techniques or tactics, and they're starting to leverage AI to help them build things like malware that can actually evade detection. So, how do we handle that challenge with all these threats coming at us constantly? Where do you start? You've got to write a correlation rule. Okay, where do you actually start? How do you know that you have the data? How do you know that you can actually, this rule will actually work, actually detect what you need? But where are you going to start with that? And what really matters? Because there's a lot of competing priorities. You have limited resources on a detection engineering team. You've got a lot of threats that you've got to be concerned about. Which ones actually matter? How do you prioritize when you need 30 detection rules? You've got a team of 2, maybe 3 people, and you need those rules, as the old saying goes, kind of yesterday. And then into threat hunting there. So when we look at threat hunting, I mean, information overload, absolutely. Again, it kind of goes back to a little bit, what threats actually matter. If I'm going to hunt for a threat, is this from even an attacker that's going to, that might target my environment? Which one of the TTPs, the IOCs actually matter? So how do I figure that out? How can AI help me do that? Understand if that threat, if that actor, if this new threat bulletin that came out is right to my environment. It's really, there's that old saying, finding a needle in a haystack. A friend of mine that I worked with at McAfee used to use this phrase, and I love it. Threat hunting, even detection engineering, all that good stuff, even the analysis side, it's not really finding a needle in a haystack. It's really like trying to find a needle in a pile of needles, really. So how do you know if you got, and it's not like it's a gold needle like Willy Wonka or anything, although that was a candy bar, so probably not the best analogy out there. But with Halloween coming up, we'll consider it a safety announcement right there. So let's take a look at analysis and triage there. So, alert fatigue. We've all kind of seen this based on that picture on the side. Your analysts, they just get overworked, they're overwhelmed, they don't necessarily feel like they're making a big impact all the time. Job satisfaction can sometimes kind of be pretty low, and in fact, we can see that, I'm skipping ahead just a bit, but by the numbers, 71% of analysts, and this was a recent study from about 2 years ago, they're experiencing some form of burnout there. So a couple of primary causes of alert fatigue really end up first with that high volume of false positives. And this has been a problem in security operations from day one. Now, is it getting better? Yeah, it's absolutely getting better. Not necessarily just due to AI, but that is one reason that we can probably see or hope to see some great improvements there. But we've gotten a better understanding of our adversaries. Things like MITRE, threat intelligence platform, sharing things like that have really helped us to get that down, but it's still high. It's still pretty high, so we've got to find some ways to do that. And that lack of prioritization that we spoke about, that becomes key because, if you've walked into SOC and you've seen a clean case queue or a clean alert screen or anything that has 2, 3 alerts on there, I'll tell you exactly what happened. Saw this years ago. There was I'm not going to name the company or anything, but an organization that I was working with, and they started missing a couple of key alerts. And of course, what's the first thing you do when you miss key alerts? You call your vendor and you say, or your partner, and you say, well, why did we miss these alerts right here? We're bringing the data in. We wrote the rules. I thought we were going to catch this. Like, yeah, I thought we would too. So start digging in. We found out exactly what was happening. So it was a model where it was basically one analyst per shift that they had on coverage. And when the Monday through Friday, 8 to 5 analysts came in, the first thing they would do is sit down in front of the alert screen at the time. We didn't have cases or anything. Hit the check all box and hit clear, because the mentality was, and it was somewhat valid back in the day, If this was a real problem, that alert's going to come back, and I'll see it again. Guess what? Did not come back because the attacker had already established persistence inside of the network, so we didn't see any of that type of initial access or any of that reconnaissance. We did see it. It just got cleared out. So needless to say, some policies, some training, things like that were actually put in place right there to help with that. Now the impact of all this, we get that desensitization. And that desensitization starts to mean, because we have a lot of false positives, because we don't have a lot of prioritization there, and we're expecting our analysts to do that, what we're actually finding is that they become desensitized to screens full of alerts, alarms going off. It's like a car alarm going off at night. And a little older, I remember, I'll date myself just a little bit, I remember back in the 80s, all these car alarms were all the rage, and you'd hear those go off, and you'd go running out and find out what's going on, only to find out, as a false alarm. Now, you're sleeping somewhere, you hear a car alarm go off. If it's not yours, you don't even go outside and look and see what's going on. If you recognize it's kind of yours, you don't go outside and see what's going on. You grab your keys and shut the alarm off. Maybe check your security camera footage nowadays. But that same type of desensitization actually happens to our work, to our analysts right there. It's like I mentioned, by the numbers, we've got 71% of analysts that say they're experiencing some form of burnout. Now that ranges from, every now and then they feel a little burnout, they take 2 or 3 days off, they feel refreshed, they come back, to that longer term burnout where they literally, that's how they kind of act every day, like the world is basically ending there. And this one surprised me. 60% of the analysts surveyed, this is a Voice of the Analyst survey, 60% said that they're experiencing increasing workloads. I would have actually thought that would be a lot higher than that, but I think that's maybe because we're addressing that false positive and that prioritization problem just a little bit right there. So, alert fatigue, AI. Well, I realize this is a little bit of an eye chart, and I didn't have the time to build the animations in because I was asked to kind of fill in here about 4 or 5 days ago here. But there's a few things that generative AI can really help us out, help us quite a bit here. One of the first ones is right up there. It's AI-generated summaries for cases. So this is an example from it. We're not going to talk about what product or what solution does this or grab the screenshots, but all vendors are really moving this way right here. So you get this, what actually happened. So this gives me a summary. Normally the information an analyst had to look at an alert and understand what was going on was that name of the alert, whatever was in that name field right there. Sometimes maybe limited to about 255 characters. Maybe there was a little longer description field, but that's also dependent on somebody filling that description field in, because I rarely see a solution where the description field does not have optional in it in parentheses next to it or has a red star next to it, meaning that it's actually mandatory. So this is actually summarizing, telling me that based on 2 alerts, 24 events, and 12 entities. So at a glance as an analyst, I'm not having to go through the screens, count things up, or anything like that. It tells me exactly what they did. This user, Tim Adler, downloaded an executable from a macro, and that source, manygoodnews.com, downloaded executables from there, and so on. So I get that summary right there. So that helps quite a bit. Then we've got AI-assisted search in number 2 right there for similar types of incidents. So what this is, think of it as basically that AI chatbot, hopefully embedded in and understands your environment. And we're seeing these, and these are not just inside of tools that you commonly find in security operations. We're seeing these in tools traditionally thought of networking like firewalls. We're seeing this in our EDR solutions, really starting to see this being built in everywhere out there. So in this case, simply asked it a question, and in the last 90 days, have I seen, what have I seen that's related to this in the last 90 days? Have I seen similar IOCs to this? Comes back and tells me that, hey, we found 11 indicators of compromise associated with APT29, and lists all those out, all those names in caps right there. Those are the names of those different, different IOCs in there. Pretty much mostly, mostly malware names right there for the most part out of there. And then we'd have a big scrolling list when we've seen those, where we've found those before. So now I know that this, as an analyst, if I'm doing this, now I know exactly, now I know that this is not isolated to a single case here, that I may have multiple cases out here for this, multiple alerts for this, and it may have affected multiple systems, so I can get those kind of summaries out of here. This saves quite a bit of time. And then here at number 3 right there. All right, well, what steps should I actually, take? A lot of times I'm searching, my online wikis and so on. All right, this happened. What's my workflow? Where do I go? Should I recommend, if I'm an analyst, on the next steps, if I'm going to pass this on, and so on out there? Well, this is literally telling me, go ahead and investigate these suspicious entities here. Suspicious entities aren't just limited to to any external kind of threats. If I've got a machine that's been compromised or a user that's downloaded a malicious file, whether that file is executed or not, that becomes a malicious entity, and it should in that case right there. So it's telling me what to investigate: file paths, usernames, malware, pieces of malware, things like that out of there. And a lot of times it's giving me links to actually run and generate those types of searches for me right there. So what this is really doing is helping to save time right there. So the lack of prioritization, same kind of thing right here. So these root causes right here, we're looking to, we kind of mentioned that. Little to no relevant alerting context right there. So I've got an alert, okay, well, it's that and. Is there a threat intelligence component to that? Is this file malicious? Has it been analyzed? Was a hash found on a threat intel list? Is it relevant to my environment at all? I've got I'm seeing an alert for, something, and I go look and I find out that this is a threat that, this threat actor tends to only target marine research stations in Antarctica. And I don't know, I'm a widget manufacturer in Canada. Maybe something that, might have a little lower prioritization, but I don't have that context without finding that. When I have to go start searching for this context, building these cases manually, again, that's taking time. What does that impact? That impacts my remediation time right there. And that ad hoc, and we talked about this, the ad hoc or the very limited prioritization that we tend to have. And I've seen some crazy prioritization models out there, and everything has been tried in this industry. Just low, medium, high. Maybe not quite enough there to throw anything into, but a good kind of starting block. And we've seen 1 to 50, 1 to 100. We've seen prioritization along with the severity, along with a risk score associated with it. Saw a system once that they never released it, but they were prototyping 1 to 100,000. They were studying that. We could do priorities from 1 to 100,000, where 100,000 is critical. Okay, what is the difference between 99,999 and 100,000? Mathematically, they could say that that was 1, but they couldn't actually tell me what that difference is. If you don't know what that difference is, you're trying way too hard on prioritization right there. It should be simple, should be easy to explain, it should have a scale that has some kind of relevancy to it. If you're using a risk score from 1 to 100, you don't necessarily need to sit here and say 99 is this, 100 is this, but at least certain ranges in there, and should be able to tell how those risk scores were actually generated. But when we have this lack of prioritization, where does that impact? Well, you mentioned it delays that incident response, because as I'm triaging this, I've got to track down, understand, do I have the right priority? And then I've got the priority of the alert, and then should that be the same priority as a case? Is this actually something deeper? Do I need to escalate this? And in escalation, I'm talking about escalate it to actually reset that priority or that severity as something a little higher out there. And oftentimes you do. And with that context, I'm throwing a few numbers in here throughout. It'll kind of vary. 40% of organizations say that they have limited visibility into their IT environment. Like, we see that as security. For those of us in here that are work in security, we see that all the time in security. When we're trying to collect security logs, when we're trying to get that data, oftentimes you'd think, okay, well, I work in security, firewall's a security device, no problem getting the logs in. Worked with customers where, well, wait, that's a network function. Even though you need those logs, we've got to go through and justify to the network group why we need those logs, what we're going to do with those logs, how we're going to handle them, how we're going to store them, how and when we're going to dispose of them and delete them. And then they ultimately get that final say of whether I get all the logs, I get a subset of what they think I need, and so on. Now extend that out, trying to get visibility into things like asset management databases and understanding the assets. Get that, other than a very simple bit of Active Directory, maybe to at least enrich users with something very limited, just so you can expose maybe a username and an email address, versus much deeper visibility that can go into all of your OUs, mine from that entire forest, look into other types of systems that can provide context. And it's not advocating for every system the environment you need to plug into for context like anything else. Is it useful? Is it going to provide value? Don't hoard data just to hoard data for data's sake, basically. So, let's look at AI and these prioritization problems. What can we actually do right there? Well, simple, again, going back towards that generative AI piece right there. So we can leverage AI to actually help us aid in that prioritization. If I've got incomplete or unclear prioritization, let's ask, let's find out. Right there, we just asked it, should this be considered a high priority threat? Now, the chatbot already knew which case I was actually talking about because of the previous questions that I'd actually asked there. So let it actually tell me if that's the case right there. And it says, why yes, APT 29 is a high priority threat. It's got advanced capabilities, targets sensitive organizations, impacts on national security, and so on. Even tells me likely to be considered a high priority threat by organizations concerned about cyber espionage and national security. So it tells me there it tends to attack nation states. Doesn't mean it's limited to it or anything, but kind of tells me that, hey, you know what, you might need to take this a little bit seriously. That takes about 5-6 seconds, counting typing time, to get those kind of answers back. However, I don't have that information. All I've got is maybe a file hash that was triggered. What's my usual workflow? Copy that file hash, go over to my threat intel console, maybe hopefully it's another tab, maybe another monitor, maybe I don't have access to it. Actually look that up, determine what it is, determine what threat actors it's related to, figure out if it's relevant to my environment, figure out if this is something I should consider a threat, but I've got to make that decision. I've got to gather that information. That can take a significant amount of time. When you're dealing with a high priority threat, time is of the essence right there. Second thing we'll show on this screen right here is how about some of my TTP summaries related to this, related to the case, to the alert that I'm looking at. Well, a lot of great tools out there to do that, but again, instead of doing that and taking that time, we just ask right there. So literally ask, can you summarize the relevant TTPs associated with the case right here? A pretty good list, gave a lot of good information, abilities to immediately dump this information into notes, into the case and so on, or copy it, wherever, whatever I want to do with it. But quick summaries there on initial access, execution, persistence. As I scroll down, I get a lot more of that data as I go through there. The third one, I'll pop that onto the other screen. This, I think, is one of the, for a lot of reasons, this, I think, is one of the big things that can really save a lot of time, but not just here. So we're going to see this will be kind of a recurring theme throughout, but especially on the side is that natural language search right there. So when we look and we think about data structures and the log taxonomy, looking at whatever that normalized, parsed, whatever you want to call it, event would actually look like, we've got a lot of fields in there. And nowadays, a lot of complexity in that field, in those fields. The people that really understand that the best outside of the vendors, and I'll tell you, the vendors, it's usually the engineering team that understands at least that structure better than anybody else. There's a lot of experts everywhere and stuff. It tends to be those people on your team that may be writing parsers, extensions to the parsers, new parsers, because they're working in that all the time. and the detection engineering team, because as we see, they have to know how that data is normalized, as we know, in order to write those rules. Our analysts, they know it, but do they know it to the point of every single thing out there? So this is going to be a very simple search that I would want to look at here. And in that search, just want to look and find Mimikatz process launched. When has that actually been launched in my environment? Now, if I'm not overly familiar with the query language and specifically those fields, I'm typically going to do some kind of high-level search, grab some events that may or may not be related, or use wildcards, look at raw logs, try to figure out where this lives somewhere, get an idea what that structure is, and then keep trying to fit that structure into a query the right way there, and understanding where I have to use quotes, where I have to use backslashes, can I use regex, what flavor of regex is it, and so on. I'm not an expert, I don't know these things. Well, natural language, I just tell it, Mimikatz process launch. Boom, spits out a search. Now, is that search perfect 100% of the time? Absolutely not. But it gives me a great starting point to actually find that information and start to narrow that search down. So this comes back and says, let's look and find where the full path to the principal process file is mimikatz.exe, but let's do that as a regular expression, and let's make sure it's case insensitive, because our adversaries think they're smarter than us, and they'll put a capital M, and I'm only going to search with a lowercase m, and I'll never find it. And it returns data. It may not be perfect data coming back in there, but it's pretty good. It gives me the ability now, where I've got lists of data, to quickly change my time frames, to actually modify that search, and to actually, I don't even need to know the query language to pivot. I could tell it to do some further summarization, or I could do things like pivot throughout here and filter things out and say, only if it's this user, only if it's on this group of hosts, or only on these dates with what other conditions. But I can start to get to that information a lot quicker. I can get to that information a lot faster, and that becomes incredibly, incredibly helpful. So how does that benefit, for analysis and triage? Well, automates a lot of those repetitive tasks right there that that we're having to do, or we can speed those up. Definitely increases the accuracy and the efficiency without a doubt. So when we talk about accuracy, using some of these Gen AI techniques, I'm validating or even learning about that, what should I consider this to be priority-wise? Helps me kind of determine if this is a false positive, if I need to escalate this up the chain, so I can gather that data faster, can analyze that data faster. I can ask AI to summarize that data and use that instead of a gut feeling. And my gut's a little off because I had a rough weekend. I'm just I was sick or something like that out there. But it's going to increase, it's going to make our SOC analysts a lot more efficient. Plus, they get a shiny new toy to play with, which is always fun. Everybody loves toys, especially in our world. And then decreases that triage and response time, because I can find that information orders of magnitude faster. I can actually decrease that time because I can ask it to summarize complex data sets. That now decreases that time. Anything that I can do to save time is key. And it matters, I won't say it doesn't matter, but it matters to a degree, the way that I'm saving that time. And what I mean by that is, if it turns out to be a false positive, I'm saving time. What that helps me with is a couple of things. One, I've identified this as false positive. Do that a few more times, the same alert fires. I've got a case to go to detection engineering or whatever function does that. Adjust the parameters on that alert, some exclude filters, whatever it might be, redo it, can the whole rule, start over, something along those lines, but it can help me to reduce that false positive volume there. If it's a true positive, something that I actually need to escalate up to, we need to respond to, generate an incident response, something like that out there. Decreasing that time is absolutely of the essence, so being able to do that kind of stuff is key. We're also seeing things like where we talk about automating those. Instead of sitting here and asking, some of the things like we saw in that, in fact, I'll go back to it, one of those very first screens right here. Number 1 here and number 3 right here, these were automatically generated by examining that case. No questions were asked, nobody interrogated the AI, prompted it, anything else like that. It just spit this information out. So that, that alone saves that time right there. And these are some of the tasks that tend to take the longest, and as we looked at, tend to be the most frustrating for our analysts. So a lot of benefits there. So let's take a look at detection. So that's a big word. A lot of things that can mean, a lot of different ways that we do detections, a lot of areas that we could actually apply this or think that we can. And this varies vendor to vendor, product to product, even within vendor itself. Different platforms are going to have different solutions, different ways of doing this. But driving towards AI to do this is going to be, going to be a huge benefit. Doesn't mean that AI is going to replace our detection engineers. It's always the worry. Well, you hear that from everybody. Oh, look at all these great AI capabilities we've got in product XYZ. Management loves to hear that. When you get down to that level of somebody like an analyst, somebody that's on the front lines, what they're hearing in their head, and it's natural human fear, is, oh, replacement. You're going to replace me. Not necessarily, not really going to replace you, going to augment you, going to make you faster, make you focus on real threats, complex problems and challenges, because that's what humans love. That's where humans excel, is really, with complex problems, with reasoning, with thought, with, and specifically with judgment out there. So detection as a problem. And this could have probably been an entire presentation titled, Why is Detection a Problem? So we've got an expanding attack surface out there. So, move more and more things to the cloud, our attack surface increases. Roll out new services, new products, that increases right there. Missing or incomplete information. So I don't have all the information I need to build detection rules. We've got to fill in those gaps right there. And these rules often need to be frequently updated. This one was interesting to me. So this is a 2024 cost of a data breach report from IBM. This is the first time, and it's probably me just missing it, but average cost of a data breach related to detection and escalation averages about $1.63 million for organizations that have experienced a data breach. So this speaks to the quality of detection and escalation right there. So that speaks to everything we just kind of looked at from an analyst perspective, where they're having to run through, do all these manual tasks, decide if it's false positive, everything else, because the rules are spitting out, or our detections or our alerts are incomplete. Turns out somebody attached a number to that, and that number shocked me. That's about 25% of the average cost of a breach right there. So there's a few areas, at least, and there's a lot more coming. I mean, we could talk about things like predictive analytics that's on the radar that we're looking at, and so on. But I wanted to focus on kind of two key areas right here. One, probably everybody is using in some way. So we'll touch on that really high level, AI-enabled detections. And the second one, kind of AI rule writing right there. How can we do that? Can that even speed up the process? Is there such a thing as letting our robots write rules for us there? Well, AI-enabled detections, machine learning, we all know this, being used, millions of different ways. On the detection side, really, we're training models to kind of understand what is normal, and have that model, keep feeding that model data, keep relearning its baseline, keep understanding exactly what is normal right there. And we're doing things like anomaly detection, where we are recognizing what's different and alerting on that. So what's different than normal? But that is, to some degree, still does produce false positives out there, because just because something is new doesn't mean something is bad. So the AI needs to be able to understand some of those subtle differences that shouldn't be alerted on. Sometimes that's just learning, feeding that results back into it. Sometimes that is feeding the results of the analysis that this is a false positive back into those models, so it can start to learn that. The longer you're running these models, the more you're training them on, the better that they're going to get on those detections right there. So what does that really give us out of there? Well, it's going to give us speed. Large sets of data, feed that into a model. It can analyze it almost instantaneously. We won't say instantaneously, but it can do that at speed greater than humans can. Go try to look through a big set of log data, trying to go through and figure out exactly which events you need to actually generate those alerts can be incredibly time consuming. Some models can help with that out there. Accuracy. So getting those models, it can be accurate because those subtle anomalies that people can miss, yeah, it's going to flag some that are false positives. But the ones it flags that are true positives, going to be hard for humans to sometimes pick that up because what our adversary is doing, they're trying to disguise their traffic as much as possible to blend in with what is normal or what they think is normal out there. So, we can detect that a little quicker. Not that humans can't detect it. I know some people are really good at that right there. And scalability. As our logs increase, as we keep going through with more and more logs and so on, we're able to actually get in that. So, running close on time here, so let me go through this kind of quickly here. So AI rule writing. So this is the old way of doing it right there. I need a rule to detect obfuscated PowerShell. So there's my challenges. What does the data look like? What fields are relevant? Do I even have this data? First thing I'd probably do, somebody's going to probably do is go, obfuscated PowerShell. Wait a minute. Let me go Google that. And, what does that look like? How is that described in the logs out there? Go search my SIM to find those events. Oh, surprise, no events are no data is found. Go enable PowerShell logging out there, search again, write the rule, test the rule, update the rule, test the rule. Fun process. And keep going through that and iterating. Only thing is the rules are a lot more complex than this. Hey AI, create a rule to detect obfuscated PowerShell commands. Here's a rule, edit in the rules editor. A little picture of it right there, the entire rule right there. All filled out, even with the author and everything there for, my metadata. But literally, and the key things, it might be a little blurry in the middle right there. Looking for command line PowerShell, and it has a flag either ENC, EP, or E right there. All of those things are true, coming from whatever user that is, and, there's my outcome. Boom, I've got a rule. I can test it, I can run it, and I'm hopefully good to go on that. So that actually works out pretty well. What that does for me is it gets rid of a few different pieces. Sometimes I still have to do some of at least number 2 right there, and frankly, a lot of times 3 and 4, and run through that because the data's not there because somebody didn't check a box to include that inside of my logging, or it's not being sent or something like that. But this gets me. I don't even need to know what obfuscated PowerShell is. I can at least go through and, it's writing that rule for me. I can run a test on it, make a few updates on it based on the results that come back, and so I can iterate through that a lot quicker. And then last kind of area where this can help us is threat hunting. So, threat hunting, same kind of challenge right there. Out there, we're looking at evolving threat actors. We're looking at huge volumes of data to go through. And I'm not just talking about your log data, but your intel data and so on out there. Relevancy, is false or a true positive when I finally find something, understanding that, and then that threat itself. And we've got a big reliance right now today on human-driven hunting right there. We can adapt AI tools to do a lot of this and to automate a lot of these threat hunting processes there. At least spit out, summarize some of that data, help me form my hypothesis, understand. Kind of leaving that same number up there, out there, because it's really kind of related still to detection and escalation, just instead of these automatic detection running through my rules, my threat hunting team is supposed to find those things that are missed, find the new and novel, find the 0 days, find those outliers that I don't have coverage for on my rules right there. So I'm going to argue that cost would probably end up being about the same there. Now, typical flow. There's a lot of ways you're looking at, intel-driven threat hunting where you're starting with, an intel bulletin or something like that. You've got hypothesis-driven. You've got event-driven. A million different ways and techniques. So what I'm showing by here is no means around any type of peak technique or anything like that. Just an idea. So a relevant actor is actively exploiting a new vulnerability. So first thing I'm going to do when I get that bulletin is go research, look in that bulletin, do a little research, gather my IOCs, including my hashes, IPs, domains, assemble all the logs that I'm going to need for affected targets, because if this is something that is exploiting an Apache vulnerability, I really don't need to go grab sets of logs that aren't relevant to that to search and hunt. Now my hunt may pivot into something more from that. Search logs for those IOC matches. Once I find those IOC matches, start looking for adjacent activity. What happened on either side of this? This was 6 days ago. What happened the day before, the day after, the week before, the week after? But still kind of narrow those, but I've got that in a narrowed down search right there. Analyze the results. Does what I find actually match this threat right here, and support what I'm hunting, what my problem is right here? There are other sources outside of my initial scope of just my Apache web servers that might need to be included. Did I see things like lateral movement, things like that? So I need to expand this scope out. Eventually, when I get all that done, I've got my results, findings, what'd you find, recommendations, next steps. High-level ways to kind of include AI in there. Well, GenAI searches to return those IOCs and those threat actor details or those TTPs and so on that can help guide a lot of those searches that I actually want to do. Summarize large volumes. Remember back we looked and said, what TTPs are associated with that, and it spit a few things out, spit out a bunch of malware names, things like that. We can do that same type of thing to build that summary right there. Use those ideas, that natural language search, to really help assist you in getting those queries off the ground, and build something that gives you a good starting point, if not a great search right there. Kind of discover, well, you know what, use those searches, find those matches, find that adjacent activity, analyze that, GenAI to summarize that large set of data and boil it down, but help you kind of generate those. So there's some of the things that we kind of see out there, and I apologize, we're kind of out of time here. So, really just, see what you can embed into your workflows with what you have, figure out where those gaps are, and then work to really expand those capabilities based on what that use case and value is. So thank you very much. Really appreciate your time.